Oh, I don't know if it's 3, 2, 1. Shoot, I didn't want to start with that. We did this today. It was fun on the board. Uh, Little contest, and then I'm going to start the notes. Start. Okay, we did this. I already did this. I told them online I was going to do this again. They're working on number 15 on their homework right now. Then after I'm done with this, I'm going to do the show the answer to number 15. Crinkle, crinkle. There he is. Okay, I don't care. I don't care. I don't care. I don't care. All right. First of all, I yelled at them if they don't know this. Oh boy. All right. That's the domain issue of this, and I yelled at them if they don't know this. That's the range issue for a rational function. That's the horizontal asymptote, and it is one of these classic. We do have to worry about this, but it is one of these classics. X equals -3. Y equals 1. It is one of these classic graphs. So this is definitely a range issue. There is no little piece in between that's covering all that. I talked about that yesterday, how that could happen. Anyway, when I say inverse, you say switch X and Y. So I'm going to do it real fast because this is now on a YouTube video. You can stop, you can pause, you can thumbs down it, thumbs up it. You can do it. You have all the power in the world to do whatever you want. All right. So, I have two Y's. So that's what I was talking about with them. The big problem here. So what can we do to get this moving? Well, cross multiply would be one way. And I will tell you the easiest thing to do probably next. No, wrong. I'm completely wrong. You don't even know what I was thinking. I got two Y's here. So I can't really like divide by X because then I still have two Y's on both sides. So I got to do something different. Do something, not nothing. Try distributing yx out of order. I don't care. 3x and then y minus 2. I still have two y's. But what you can do is get the y's on the same side by subtraction. And then since I got the y's on the same side, I don't want that 3x there. Subtract it. Whatever you do to one side, say it. And I did that, but without writing it. You don't have to write it every time. We should be moving on from that. And then real quick, because I want to get ready with these guys to show them, you take out a y and you're left with x minus 1. Don't forget about that 1, because when I throw this back in, that's the whole point of good FOILers, good factors. You check your answer. Does it make sense? Is it sensical? And then equals -3x minus 2. And then you divide. And then you call this inverse of f of x. Because I got to speed this up. The second hour is always going crazy. They're fighting. They're talking. He's drinking his water for the 43rd time. Teaching in America. Okay, so now watch this. What can't x equal in our answer here? And the domain of this is x cannot equal 1. And then what can't y equal? She gone. Y can equal. They're walking around the classroom. Mass hysteria. Look at that. The domain of the original is the range of the new. The range of the original is the domain of the new. This isn't always. Okay. All right. So back to class. Okay. So I did the video again for these guys. We did this in class beforehand. So I redid this one. You saw that. Now here's your answer. If you truly did do what you said you were going to do, how many people have that answer for number 15? We did it. Okay. There's a key so you can check it yourself and all the work that a glorious math teacher has done for you. So, yeah. All right. And some people figured this out on their own yesterday. Some came to tutoring. I had a whole smattering of people come to tutoring, and we all did that question. We actually literally did. Okay. Now, what do I have? I have 14 minutes. I might be okay. This is really rough, though. So I am going to go through this real quick. The first one's kind of hard. How do I do this? This is so they can do an extrapolation. Look at it's f of g of 1, g of f of 1. So it's switched. They're trying to make a connection. I didn't do this last hour. I kind of skipped over it. Thought he had his hand up. All right. What's g of 1? Come on, everybody. What's g of 1? What's g of 1? 1 over 4. Okay. Oh, no. It's 1 over 4. This is where I shut down last hour. I'm like, gosh, why did it make this so challenging? Okay, so what's f of 1/4? I'm going to blow your mind with some magical math. Okay, 1 minus 3 times 1/4 over 1/4, right? Isn't that what g of 1/4 is? Look at the highlighting. Wherever there's an x, I got to replace it with that. But here's how I did this last hour, Fumble. I talked about it again, just like I talked about it in our little game in the beginning. What does dividing by 1/4 mean? Maybe I didn't. No, maybe this didn't happen. Maybe I'm thinking of last hour. What's divided by 1/4? Multiplying by what? Divided by 1/4 is multiplying by 4. And I decided to rewrite this like this right in the middle of my work. And then instead of getting fractions at all, I just distributed this. That's easy for me to say. 4 times 1. What's 4 times a fourth? What's 4 times a fourth? 1. So literally this becomes 4 minus 3, which is 1. Isn't that wild? Yeah. And you know what? What did I plug in? What did I plug in for x? What did I plug in? 1. This is weird. Now let's now do g of f of 1 and hope it's not as bad. So f of 1, let's change the colors. F of 1 is g of, and then this is 1 minus 3 times 1 over 1, right? Okay. And then what does that become? Isn't that negative 2? It's negative 2 over 1. I just want to make sure I'm not making a mistake. Interesting. And then what's g of negative 2? What's negative 2 plus 3? What's negative 2 plus 3? What's 1 over 1? 1 again. And then I don't have time for this. The same thing would have happened with these two. Actually, that's weird. Yeah. Where am I at? F of h of 2. No, I don't really know what the connection is here. But what we got here is these are inverses of each other. So whatever I plugged in, this is what I resulted in. The same thing. So here's where our test is. All right. Undoes all the operations. Okay, I'm just going to go to it. And here's what we're going to be doing today to prove two inverses are equal, or two functions are inverses of each other. Sorry, kind of messing up my language here. And this is what's true about inverses. Now, let's calm down a second and think about what's happened the last 3 days of notes. I think 3 days ago we did compositions. We did that thing, that stuff up there. But then we did f of g of x and g of f of x, and I told you algebra is back. Well, now this is a test to prove two functions are inverses of each other. But you got to do two tests. You got to compose and plug in the inverse into the original function, and then vice versa. When you do this, you will get x as a result. Just like in the first thing that we showed you up there, of course, you don't know this, but by default, not by default, but behind the scenes, these two functions are actually inverses of each other. And look at when I did g of f of 1 and f of g of 1, I got 1 in both cases. Well, when I do f of g of x and g of f of x, I get x as a result if they truly are inverses. This is called the identity function. No one usually calls it that much anymore. So here's what you got to do. Look at the directions. Use composition to identify if the two functions are inverses of each other. If they are, I will get x as an answer. So here's your work. You have two things. Number one, because of time, we're just jumping into it. This is the memorization factor. It's all algebra. This is why I told you about your algebra skills. Got to be brushed up. Got to be. Number one, what's f of g of x? Well, I got to plug in g of x for its name. So g of x is a name. 1/2 of x minus 4 is its function value, I guess, how it's defined. And then input, say it. It is an input output, but what I have to input for x is that 1/2 x minus 4. So I got to show this algebra. I'm going to stay purple, and I'm going to go all the way across because of the way this work is lined up. So this is 2 times 1/2 x minus 4 plus 8. and I'll do that highlighting. And I get the chance to erase my highlighting. You do not. So the next step, you won't be able to highlight if you are. What's 2 times a half? Oh, I went to red. What's 2 times a half? 1. Good. I heard one person. What's 2 times -4? Do me a favor and tell me this is x minus 8 plus 8, and then cancel those 8s and say, you know what? I got x. That's why I'm putting a check. That's always my good check. Like, yes, this is what I was supposed to see by Mr. Samuelis's, rules and definitions and things that you just have to remember and accept. Yeah, this is when you just have to accept and do. All right. You have to do these compositions and then see that you end up with x when you're done. Sorry, as a brain mishap. G of f of x. Okay, now I'm going to cheat. I'm going to erase my highlighting for your eyeballs so you can see what's going on here. So I replace f of x with its functional value. So, and I'll stay blue. So this is g of f of x is 2x plus 8. And then I'll green this again and go over here and green that. Okay, in the g function, wherever there's an x, I got to put a 2x plus 8 in its place. So half 2x plus 8, and then -4. And then I'll highlight that one more time. That's what replaced x. Yet again, everybody, what's half of 2x? What's half of 2? 1. What's half of 8? 4. So you get x plus 4 minus 4. We can cancel those and put a check baby, and say, yes, they are inverses. Okay, it is a weird, different thing, but this is the proof of it. This is a attribute of inverses that we need to know and lock in. It's all algebra. Okay, the second one is going to be tough. I'll put this up here for a second. Check our time for those that are catching up. I know you have to look up, down. 6 minutes. Okay, now, honestly, look at your homework while I'm waiting for people to finish. You only have to do this in 9 and 10. 8 before that, it's just find the inverses one more time, one more practice at it. You have a fractional one in there again. Hopefully we can do that and be done with this and then move on to, I think, logarithms tomorrow. Oh, I love logarithms. I love our upcoming thing that we're going to do. Okay, no highlighting. F of g of x. Here's g of x. So f of 2 over x minus 3. And then no highlighting. F of, wherever there's an x, I'm putting that in its place. So this is, 2 over x minus 3 plus 3. Right? Okay, so I put this in here, but I don't really need that block in there. Because what's minus 3 plus 3? What's minus 3 plus 3? Cancel. And then this kills me. What operation is this? What operation is that? It starts with a D. And we actually did this today in the previous thing. Division. How do I divide by 2 over x? I multiply by x over 2. This is not rocket science. This is not engineering. Oh, I should have used that line in first hour. All right. And then the 2's cancel. This is basic math. And I get x by that happening. So I didn't freak out when I saw fractions within fractions. I understood the divide by a fraction rule. Grade school. All right. And then I'm going to go ahead and flip it around. Maybe blue is good offsetting red. Make it look way different. I got a whistle, and then I got a teaching in America. 2 over x plus 3. What'd you say? Try teaching where? I thought you said something. Teaching in America. Did you hear him? 2 over x plus 3. And then minus a big fat 3, right? So that's where I put that x in. G of x, I put 2 over blah minus 3. Yet again, what operation is this, everybody? The division. This is free of that. So this turns into 2 times what? Times what? Times what? No. Times x plus 3 over 2. Time for a drink. Time for a drink. Time for a drink. And then what happens to the 2's? What happens to the 2's? They cancel. And then you would have x plus 3 minus 3, which is what, everyone? X. Now watch how fast the last one is. This is the worst one. All right, but honestly, you guys, we got to get this algebra done, man. I've talked about fractions all year long. I've talked about dividing by a fraction is flip multiply. All right, we got to be able to handle the algebra and not make up goofy rules. Watch how easy this one is. I'll do h of g of x first. These are usually the case pretty fast, and linear isn't so bad either, although we did have some fractions. H of, okay, g of x, which is root x minus 10. By the way, we have this condition here because I got to keep it 1 to 1. The function, I talked about that during, there's no time. I can't keep repeating myself. We're either going to get it or we're not. All right, and then go to the h function, wherever there's an x, plug in root x minus 10. What's root squared? What happens? Cancel is correct. That's all we're looking for. So when these cancel, humor me, don't write too much, don't do too much in one step. What happens to the 10s then? Cancel again. And then you can say check baby, 1, 2, 3. But you're not done. You got to do the reverse. And it's just as easy. So sometimes they're not as bad as we present. H of x is x squared plus 10. And then g of that is, wherever there's an x, plug this in its place. So that's root x squared plus 10 minus 10. I'm going to put parentheses, but they're useless. What's plus 10 minus 10? What's plus 10 minus 10? And then what's the square root of x squared? X. That's all you got to do. Drop it like it's hot. Okay, so I know this comes out of left field. They tried to do a little extrapolation with input output in the g of f of scenario. Really, the brass tacks of it is you just got to know this attribute. Got to know this attribute. If functions are truly inverses, then g of f of x and f of g of x will both equal x.